Welcome to Snacks Weekly on Data Science. This podcast is all about making data science and machine learning knowledge accessible and less intimidating. Today, we are going to talk about large language model applications. This topic is based on a tech blog with the title An Autonomous Agent for Agile Planning, written by a software engineering from Walmart. You can find the blog link in this episode's description. Throughout this episode, we'll dissect the topic from both business and technology angles. Now, let's dive in. On the business side, let's take a look at the problem to be solved. Walmart is an American multinational retail corporation with over 10,000 physical stores worldwide. It also has its own e-commerce business. Many aspects of its operations rely on software engineering. Given the complexity of its business, a proper project management process for software engineering is essential for the success. The agile process is a project management approach that involves in breaking the project into phases and emphasize on continuous collaboration and improvement. Under the agile process, the teams follow a cycle of planning, executing, and evaluating, with each cycle takes approximately 2 to 4 weeks. And each of the cycle is called a sprint. The agile process is a commonly leveraged project management approach, especially among technology companies. With almost 86% of software developers use Agile in their work as by end of 2023. The software engineering team inside Walmart also leverages the Agile process to manage their project cycles. Within the Agile process, sprint planning is a stage where a team needs to decide which tasks to complete in an upcoming sprint and how that work will be achieved. In the case of Walmart, business and product managers collaborated together to outline the product goals for next quarter. The business goals are then distilled by engineering managers into a comprehensive list of software features. Once the features are finalized, the full quarter is usually divided into 4 to 6 sprints. As you can see, to effectively make the sprint planning, the team needs to divide each business goal into a list of tasks, and then write out elaborative information around it to make clear about what is the product requirement, a description, dependencies, acceptance criteria, and effort estimation. However, the problem is that for software engineers, their expertise may not be in effective writing. So this usually takes them days of work to write out those tasks for sprint planning. This is not efficient, and the team would like to leverage better tools, such as large language model, to help improve their efficiency. Now that we've understood the business problem to solve, let's shift gear and dive into the technology side to see what is their solution. Large language model is a type of artificial intelligence model that has been trained on massive amounts of text data to understand and generate human-like language. These models are capable of understanding context generating coherent text, and even completing prompts or questions based on the patterns and information presented in their training data. If you may have ChatGPT or any other generative AI service account, I recommend to simply try it out. I asked ChatGPT one question: to write me a 5-minute kid story to help with a 5-year-old boy to sleep. It generated a storyline about a sleepy cloud named Skylar embarks on an adventure to find the sleepy meadow with the help of the moon and a wise owl. This is pretty creative and impressive. Giving LLM is already very powerful. At the ideal situation, the team can directly ask one question to the LLM model. For example, by saying, create all the tasks based on this product requirement doc. And then, hopefully, the problem can be solved. However, this is not that simple due to the following two challenges. The first challenge is that there is a natural hierarchy in the sprint planning process, where it involves roughly 3 stages. 1. Team need to identify the list of potential tasks and their dependencies. 2 is to write out the detailed task description. The third is to properly size and assign the level of effort. It is hard to directly make one LLM request and get all of these tasks answered. The second challenge is that it is hard for LLM model to know exactly what are those informations needed to prepare for writing up a good sprint task. Based on the team's research, they found that people commonly refer to internal documentations to write up the details and then estimate the effort. These internal docs including the corporate guidelines about how to use agile process and some concepts like how to define a feature, story, acceptance criteria. And also there were many previous knowledge about how previous sprint planning was done and the previous product requirement docs. These are all very useful information to help with writing new sprint planning doc. Any of the commercial or open source LLM model would not have this information encoded in their training datasets, so they lack the context of this information. With these two challenges, the team formulated two approaches to address the problem. To address the first problem, because of the complexity of planning, the team developed a framework to make sequential LLM queries. The first LLM request is called a sprint planner. This is a prompt that plans out the timeline and divides the goals into a series of tasks. The second request is called a story groomer. This LLM call generates a story headline, description, and acceptance criteria for each of the tasks generated by the previous sprint planner. The third request is called a story sizer, where its goal is to estimate the level of efforts based on both the acceptance criteria as well as historical knowledge on how the sizing works. With these 3 sequential LLM queries, the team is able to mimic the flow of sprint planning process to address the complexity challenge. Now let's take a look at the second challenge, where commercial or open source LLM cannot have the private or internal information. To address this challenge, the team leverages the Retrieval Augmented Generation technology, or simply called RAG, RAG. RAG uses an information retrieval system to improve the reliability of generative AI models. Let's take a look at a simple example about a hypothetical question and answer system for a medical database to see how RAG helps to boost the performance of a standard LLM model. It basically involves following phases. The first phase of RAG is to prepare the knowledge base. Let's say a medical database is created with various articles and documents related to the most up-to-date medical understanding. And each of the database is indexed and encoded into a vector representation using the RAG technology. This vector representation captures the semantic meaning of all the documents. Then, when a user submits the question to the system, saying, "What is the common symptoms of influenza?" this retrieval phase is kicked on. In this phase, the system utilizes the RAG component to search the indexed medical database for relevant documents related to influenza symptoms. The RAG will retrieve a set of documents from the database that contextually related to the user's query. Then it will append this retrieved index along with the prompt asked by the user to the LLM model to generate results. In this example, RAG helps in the retrieval of relevant information from the knowledge base, and LLM leverages this information to generate a natural language response. The combination of retrieval and generation allows the system to provide accurate and contextual appropriate answer to user queries. As you can see, this approach is particularly useful in the current agile planning case, as it requires private sourced and updated information to be leveraged to enhance the generative capability of existing language model. The team combines both the sequential query framework and the RAG technology to build up their service. It is demonstrated that this service can help dramatically improve the sprint planning efficiency, making the time required to write out sprint planning docs from days to minutes. Now we discussed both the business problem and technical solution. Let's wrap it up. In this episode, we introduced what is the agile process for software engineering development. We also discussed how the software engineering team at Walmart leverages large language model along with retrieval augmented generation technology to build an intelligent agent to improve their agile planning efficiency. If you like the content of this episode, please subscribe to the channel, give me a 5-star review, and leave a comment. Your feedback is very appreciated, and I'll see you next week.